Today we're going to revisit some of our equations that we saw back in Chapter 2. So we're going to talk about our absolute value equations, our rational equations, and our square root equations. The only difference between what we did back in Chapter 2 and what we're going to do as we're going through this section is that now our universal set and our domain is going to be considered that of real numbers. So we're going to start with the absolute value equations. When we are solving absolute value equations, the first thing we want to do is we want to make sure that our absolute value is isolated or by itself on one side of the equation. That means if we have any extra numbers outside of the absolute value, those have to be moved before we can begin the equation. Once we have done that, then we're going to look at the number that's on the right side of our equal sign. If it is positive, we're going to have two equations to solve. We're going to set our expression equal to that positive number and then also set our expression equal to that negative number. If we do start with a negative number on the other side, then immediately we stop. We cannot proceed. No solution is possible because it's impossible for absolute value to be negative. And if we have a 0 on the other side, then our expression is going to be equal to 0. There is no such thing as positive or negative 0, so we only have one equation to solve. All right, so for example A, so solve, write each answer as a solution set. So looking at what we have here, we have a positive 4 on the right side of our equation. So we're going to start by writing 3x plus 2 equals positive 4, 3x plus 2 equals negative 4. Right. Then we're going to solve each of these equations for x. We subtract 2 from both sides, we get 3x equals 2. Divide by 3, we get x equals 2/3. Subtract 2 from both sides, 3x equals negative 6. Divide by 3, x equals negative 2. Right, both of these answers are real numbers, so our solution set is going to contain a positive 2/3 and a negative 2. For example B, notice that our absolute value is not by itself or isolated on the left side of our equation. So the first thing we are going to do is we are going to subtract 3 from both sides. Now we have the absolute value of 5x minus 6 is equal to negative 1. Now that our absolute value is isolated on the left side, we look at the number on the right side. We have a negative number here. It is not possible for our absolute value to be equal to a negative number. So our solution set for the second example is going to be the empty set. Right, then for C, down at the bottom, we have the absolute value of 2x plus 4 equals 0. So we're only going to have one equation to solve. We're going to subtract 4 from both sides. 2x equals negative 4. Divide by 2. X equals negative 2. So our solution set is going to contain the number negative 2. So absolute value equations, key things to remember. Right, make sure absolute value is isolated on one side of the equation, and then based on the sign that's on the other side, that's going to tell us how we're going to solve this. Right, next we're going to talk about rational expressions. Rational expressions we saw back in section 2.7. When we were doing problems with rational expressions previously this semester, we talked a lot about domains, we talked about simplifying, and we talked about solving equations. We're going to review our domains and our equation solving processes. As we're going through these problems, the first thing we're going to do is we're going to find our domain restrictions. We're going to take our denominator, say our denominator cannot be equal to 0, and then use that to tell us what's going to be left in our domain. Once we do that, we're going to find the LCD, multiply both sides of our equation by the least common denominator, and then go through and solve. So distribute, solve, and then we're going to check our solution in the original equation, make sure it's not one of the domain values that has already been excluded. So example 2 down at the bottom. Right, so we're going to solve our rational equations, first state any domain restrictions, and then we're going to write our final answer in a solution set. Right, so for our domain, we're always going to use our set builder notation. So in this case, our universal set, our domain that we're starting with, is the real numbers. So we start with x such that x is an element of the real number. And then we're going to take our denominator. The only denominator that we have is x plus 1. So x plus 1 cannot be equal to 0. We subtract 1 from both sides, so x cannot be equal to negative 1. So that is our domain restriction that we fill in here. Okay. After we do that, well, we need to find our LCD. Well, our LCD is our least common denominator. In this case, our only denominator that we have is x plus 1. Right? Generally speaking, when we're doing our multiplying and stuff, we put these in parentheses just to make sure we distribute as needed. Right? So going back to our equation, we're going to multiply all three pieces of our equation by x plus 1. Right? Now looking at our first part, we're going to have 3 times x plus 1. In this next part, these x plus 1s are going to cancel out. So we're just going to have a 1. And then we're going to have 5 times x plus 1 left on the other side of our equation. Now we're going to go ahead and distribute, simplify, make our problem look as nice as possible. So 3x plus 3 plus 1 equals 5x plus 5. So we distributed our 3 and our 5. 3x plus 4 equals 5x plus 5, combined like terms. Now I'm going to subtract 4 from both sides. 3x equals 5x plus 1. Subtract 5x from both sides. Negative 2x equals 1. Divide by negative 2. X equals negative 1/2. We double checked that this value that we just got for x was not an excluded value in our domain. It was not, so we are done, and our solution set for this example contains negative 1/2. Right, for example B on the next page, we're going to start by thinking about our domain. So again, thinking about our domain, we're thinking about our denominators. So looking at our denominators, we do have different denominators this time around. So as we are looking at these and thinking about these, we are going to factor this middle denominator. If we take out a GCF in this middle denominator, we have y times y plus 2. Right? And the reason we want to do that is when we're thinking about our domains, when we're thinking about our least common denominator, if we have anything in our denominators that can be factored, we want to make sure we take care of that first. All right, so for our domain for this problem, again, we're going to start with x such that x is a real number, right? And we need to figure out what values we want to exclude. Well, looking at our denominators, we have two different factors. Right? So one of our factors is y. So y all by itself cannot be equal to 0. Our other factor that we have for our denominator is y plus 2. So y plus 2 can also not be equal to 0. If we subtract 2 from both sides, then we get y cannot be equal to negative 2. So our domain restrictions are going to include y cannot be 0, y cannot be equal to negative 2. Right, now we're going to find our least common denominator. Again, our least common denominator is built of all of our factors in our denominators. So in this case, our least common denominator is going to include a factor of y and a factor of y plus 2. So we're going to take this y times y plus 2 and multiply it by all three parts of our problem. All right, now in our first expression, our y's are going to cancel, and we're going to be left with 5 times y plus 2. Right? And our next part of our expression, everything's going to cancel. Our y and our y plus 2 are both going to cancel, and we're just going to have a plus 6 left. Right? Then on the other side, we're going to keep that negative 3. Our y plus 2's cancel, so we just have negative 3 times y. So again, we're going to distribute and simplify. So 5y plus 10 plus 6 equals negative 3y. 5y plus 16 equals negative 3y. I'm going to subtract 5y from both sides. 16 equals negative 8y. divide both sides by -8, y equals -2. Right. Now we're going to go back up to our domain restrictions. Right. Those should be y's. All y's such that y is a real number. Y cannot be equal to 0, y cannot be equal to -2. So even though we got -2 as our solution down here, it's an excluded value in our domain. So since this is an excluded value, we cannot use our -2 as a solution. We don't have any other solutions to consider, so our final answer is going to be the empty set. All right, for example C, we're going to go through the same process. We're going to start by looking at our domain. Right. All x such that x is a real number. Right. Looking at our denominator, the only denominator we have is x plus 3. So x plus 3 cannot be equal to 0. That means that x cannot be equal to -3 if we subtract 3 from both sides. Our LCD, again, it's our only denominator. Our LCD is going to be x plus 3. Right, so we're going to multiply this by all parts of our equation. In our first part, the x plus 3's cancel. We're left with 5. In our second part, we still have the x times x plus 3. And then on the other side, our x plus 3's cancel, and we have 3x plus 14. Now we're going to distribute, combine like terms, simplify. So we have 5 plus x squared plus 3x equals 3x plus 14. We're going to move all of these numbers on this side over. Before I do that, I'm just going to kind of rearrange these ones on the left so our terms are in descending order. So x squared plus 3x plus 5 equals 3x plus 14. You don't necessarily have to reorder them if you don't want to. You can jump right to the next step if you prefer. So anytime we have an x squared, we have to get our equation equal to 0 so we can try to factor it. If we can't factor, if you choose not to factor, you can always use your quadratic formula that we talked about in the previous section. Right, so I'm going to eliminate this positive 3x, so I'm going to subtract 3x from both sides, and then I'm going to subtract 14 from both sides. So on this left side, I now have x squared. Those 3x's cancel. 5 minus 14 gives us -9. On the right side, everything cancels and we're left with 0. Now what we have left, again, we can either try to factor or use our quadratic formula. This one factors nicely into x plus 3 times x minus 3. It is a difference of squares. So either x plus 3 equals 0 or x minus 3 equals 0. We subtract 3 from both sides, we get -3. We add 3 to both sides, we get +3. Now we're going to go check our values with our domain. Our domain restriction said that x cannot be equal to -3. So this is a value that's excluded in our domain. So we don't want to use that as a solution. We're just going to use our x equals +3. So our final solution set for this problem is just going to include our +3. All right, so our rational equations, again, as we're going through, the only differences now, we have real numbers as our domain, but as we're thinking about these, again, we're looking back and using the same stuff that we talked about in section 2.7. All right, our last type of problem that we're going to revisit in this section is going to be our square root equations. As we are working through our square root equations, our first step is similar to what we see for our absolute values. If our square root expression is not all by itself, make sure we move numbers to the other side. Then we use our power rule to square each side, solve what we have left, and then in this case we do want to make sure that we solve for extraneous solutions. So we want to make sure that we solve when we don't have any extra solutions. All right, so for example A, We have 2x minus 3 inside our square root is equal to 2. So we're going to square both sides of our equation. On the left side, our square and our square root essentially cancel each other out. Right? So we are going to have a 2x minus 3 left on that side. On the right side, we're actually going to square our 2. 2 squared is 4. Now we're going to solve the nice little equation that we have left. So we're going to add 3 to both sides. We get 2x equals 7. Divide by 2. X equals 7 over 2. 7 over 2 is a real number, so that's going to be our answer in our solution set. One thing that we do want to double check and make sure, it's not necessarily as big of a deal with this first example as it will be with our second example. We do want to make sure that when we plug something into our square root, we still get a positive number. So before we move on to the next problem, right, we are still going to check, right, that if we take 2 times 7 over 2 minus 3, that we get a positive 2. Our 2's cancel, so the square root of 7 minus 3 equals 2. Well, the square root of 4 does equal 2, so our check does work. Again, generally, if you only end up with one solution, almost always it's going to check for one solution. But in our next example, example B, we're going to have 2 solutions, and only one of them is going to work. Right. So for B, we start with our square root of 7 minus x is equal to x minus 1. We are going to square both sides. On the left side, we get 7 minus x. On the right side, we need to remember, and I'm going to write out this middle step just to remind us, we need to make sure that we multiply this out, right? That we FOIL, that we distribute, whatever you want to call it, but that we actually go through the process on the right side to multiply and get all of those different terms. Right? We're not just going to take x squared and 1 squared. Right. All right, so on this right side, x times x is x squared, x times negative 1 is negative 1x, x times negative 1 is negative 1x, negative 1 times negative 1 is positive 1. Right? So we multiply and distribute that out to get all 4 terms. We're going to combine those middle 2 terms. So we get x squared minus 2x plus 1. Anytime we have an x squared, we want to try to factor, right? Or use our quadratic formula. So I'm going to subtract 7 from both sides and add x to both sides. I chose to get rid of those because we want to get anything that's not next to the x squared on the same side as the x squared. So 0 equals x squared minus 1x minus 6. Right, so here we're going to factor. Again, if you choose not to factor, you could always use your quadratic formula. We need 2 numbers that multiply to give us negative 6, add to give us negative 1. So we're going to use a negative 3 and a positive 2. Right, set both of those equal to 0. X equals 3, or x equals negative 2. All right, now both of these are real numbers, so potentially both of these could end up in our solution set. But before we do that, we're going to go through and we're going to check these, make sure that we don't get any unwanted negative numbers. All right, so first we're going to plug in the 3. Square root of 7 minus 3 equals 3 minus 1. Square root of 4 equals 2. So our 3 works. Now we're going to check our answer of negative 2. 7 minus negative 2 equals negative 2 minus 1. 7 minus negative 2 is really 7 plus 2. 7 plus 2 is 9. On the right side, this is where we run into an issue. We can't have a negative number because we are still thinking in this case, unlike our quadratic formula, that we're looking for a principal square root. So even though we've used positives and negatives when we're dealing with our quadratic formula, when we're thinking about our square root equations, we still want this number on the right side to be a positive. Right, so that means that we're not going to include our negative 2 as our solution, right, because that one does not check. It does not give us a positive number. So our solution set for this answer is going to be simply